Well, thank you very much to everybody for joining this third webinar in the Autonomous Vessels series from our Maritime Navigation Group at the Royal Institute of Navigation. I'm John Pottle, I'm the director of the RIN. My job today is a bit in the background. I'm going to give you a little bit of an introduction to how this webinar is going to run, and then I'll hand over to Ivana, who is chair of our Maritime Navigation Group, and Ivana will then be the MC of the webinar as we go through. So in terms of housekeeping, it's pretty straightforward. I think we're all pretty familiar with webinars these days. You are welcome to ask questions at any point as we go through. We would very much encourage that. Remember, there's no such thing as a bad question. Anything that occurs to you, please just pop it in the Q&A box on the bottom of your screen, or wherever the Zoom webinar bar is on your screen. And then at the end of the webinar, we will pose questions to the speakers, or Ivana will pose questions to the speakers. If you experience any technical issues as we go through, often by far the best thing to do is just to leave and rejoin on the same link. That can solve the technical issues. But if you'd like to contact me during the webinar, I'll be monitoring the chat. So there's a chat box. Zoom webinar doesn't allow participants to chat with each other. I think the theory is to focus on the content, but you can chat with me as technical host, and I'll try and help you out if you've got any questions, any technical questions anyway. I'd like you to know that we are recording this session. And afterwards, we will certainly make the webinar available on our YouTube channel. We might not cover all of the Q&A. We like to check with the panelists that they're happy for all of their questions in the not so prepared section, the more ad hoc discussion section at the end. But certainly the bulk of the webinar will be shared in the public domain on our YouTube channel. The aim of the RIN is to share knowledge and build understanding. So that's in line with that. And you, as participants, will get an email after the webinar, which will point you to that link. So you should get that within, certainly within a week, maybe within a few days. So with that said, I would like to hand over to Ivana and invite her to take us through. Ivana, please.
Thank you very much, John. Yes, welcome everybody. As has been said, this is the third part and final part of our Autonomous Vessels series. If you would like to catch up with the first two, you can find those on the Royal Institute of Navigation's YouTube channel. So just a little recap. In the first part, Tom Howe took us through an introductory overview of autonomous vessels, sort of a high-level look at what's already out there and what's going on, and a bit of a reality check as to how far we've actually got in the automated world at sea. And then the second part looked at more the technological side, including some of the limitations. We even saw how guano was an issue on cameras. But if you'd like to have a look at that, we had three fabulous speakers: Anne Pletchk, David Pollett and Tom Southall, and yet we got a good insight into IALA and their thoughts of the future of autonomous vessels, what was likely and what's probable. So this brings us on to our third part, where we're looking more at the regulation and the traffic management side. We were already getting quite a few questions on this in the first two webinars, and we did field them to this webinar. So please do have your questions ready. I'm going to introduce the panel now, and they're going to have a short presentation for you. The main bulk of this will be Q&A, so do have have those ready as you start hearing to our speakers. So I'm going to introduce you to Simon Rickett from the Maritime and Coast Guard Agency, Commander Michael Hutchinson from the Royal Navy, Gordon Meadow from SeaBot Maritime, Paul Burton from the UK Hydrographics Office, and Caitlin Bentley from King's College London. Firstly, can we start with you, Simon Rickett?
Of course. Thank you very much, Ivana. Good morning, everybody. Thanks very much for inviting me, and I'll echo the sentiment for the last couple of webinars, which I found very interesting. So hopefully I'll be able to contribute in such a way to this one as well. I expect most of you read the bio online, so I won't go full into my background life story, but I work as navigation technology lead here at the MCA. And that in our team, we have the UK's ownership of jurisdiction over SOLAS Chapter 5 and the call regs, amongst a few other domestic items. And I'm working to provide the link between that and the advent of maritime autonomy. I do have a few slides, which we'll go through very shortly. They are in part stock files, so I do apologise if some people have seen them before, especially with some of the events recently, but I do hope to provide an update. And I am very much on the navigation side of things. I can take away any questions to the rest of our team in terms of training or otherwise as needed, rather than just try and guess their answers. But yeah, the first slide we've got with a quick timeline overview of where we've been and where we're hopefully going. Most will be aware of the scoping exercise back in 2017 to 18 by the IMO, and this ties in with the UK starting to develop regulations for domestic vessels as well. We currently sit still in the drafting stage for IMO regulations, which I'll go through shortly, but we do also now have more established routes within the UK domestic framework, especially for vessels sub 24 meters, which again I'll cover later today. And as for the rest, as a former meteorologist, I'm very much au fait with sticking my finger up in the air occasionally, and there is an element of that with the dates moving forwards, not necessarily because we don't have a plan, but a lot of this is depending on the uptake, and of course, as with any innovation, the final results really do rely on industry buy-in when it comes to the latter stages. So we see a very busy environment at the moment, quite diverse sector, but the commercial uptake is still quite low, and so that's where we're looking to predict what exact types and shape these vessels will take, and what kind of operations we'll look to in the future. But IMO regs hopefully will come into force as a more mandatory method in 2032. So 2040 is business as usual. In some forms it will be, in some forms, of course, technology will still be developing. So we'll wait and see. Next slide, please. So the IMO mass code, I think most here will now be familiar with the concept of the code and where it came from. But over the past few years, the UK has continued to play a major part in the development of this. And me personally, I've been offering the technical navigation input to the UK delegation. So when you look at the chapters specifically concerning navigation, of course, you've got remote operations, search and rescue, all those areas where SOLAS Chapter 5 or call regs begin to get touched. Parts 1 and 2 will be more generic for pretty much all mass of any types, and then part 3 is where there's more in-depth guidance, hopefully for specific operations or specific technologies. On the left, the main headlines. So it remains a goal-based code, which everyone thinks is quite new for the IMO, and it is relatively new, but other codes recently, such as the Polar Code, were also made under goal-based standards framework. So it has been tried before. Cargo vessels only, although we are aware, of course, that does include up to 12 passengers in some cases, and non-mandatory code still timetabled for 2025. At what stage in 2025? We're not sure, but I would lean towards the latter part. And then we're now introducing, or the IMO has introduced, as one of the major updates recently, an experience building phase with a shift of the mandatory code to 2032 vice what was originally 2028, I believe. So this phase will allow effectively lessons learned, which for us is very positive, and then we'll revisit the code from 2028 onwards for a couple of years to hopefully refine and modify as necessary, whereas before this wasn't necessarily an option. So from a UK perspective, this is positive, as we can start to build on experience over the next over the next decade, effectively. And the next slide, sorry. And a few key principles. Again, the code, as most of you may know, is supplementary to applied-based instruments such as SOLAS. So very similar to how other codes conventional operators may use, so polar code, high-speed craft, etc. And address mass functions as far as they are not adequately and fully addressed in the applied instruments. So this has been a real sticking point at times during discussions about how much depth the code goes into. So I haven't got a full list, a full draft to share at the moment, of course, but hopefully that will be available soon. But some may be shocked about maybe how little is mentioned, and some may be shocked about how much depth it goes into. But the aim, of course, is that SOLAS, for example, applies, and we modify where necessary. So the aim is to keep this as close as possible to what conventional vessels require. And a few points on the master at the end. So there should be, these are generally agreed, I believe, are pretty much finalized. So there should be a master or human master responsible for a mass. A master may not need to be on board depending on technology used and human presence, and a master of a mass should have the means to intervene. So a few really interesting points here is that started to shape people's views of what mass will look like in the future. Obviously, this means a human will 99% of the time, in fact, if not 100% of the time, always remain in the loop. And their ability to intervene, or the requirement for them to intervene, effectively makes every mass a remote operated one in some form or at some point, which is quite interesting, and certainly has put to bed some of the misconceptions perhaps in the early stages of robot ships, and these will be coming self-driving almost from the offset. Moving to the domestic world in the UK, so three main routes now for an operator to, or operators to use to get their vessels certified or operating under the UK flag. A little bit of a light touch, but hopefully some of you will see that over the last few years, from going from 0 to now 2 to 3 established routes is quite positive. At the lower end, we've got the recently released MGN 702. So this is a general exemption, or general exemption on certain aspects for vessels sub 2.5 meters in length. And there is looking to be a second bracket between 2.5 and approximately 4.5 later in the year, but that's not yet finalized. And that really links to the Workboat Code Edition 3, which was launched at the end of last year, or late last year, and specifically Annex 2 to this document, which gives guidance on the standards for remotely operated uncrewed vessels. This was the first time that domestic legislation opened up to autonomy in a more formalized fashion, and it develops from the conventional workboat codes, so Workboat Code 2, of course, and how we can apply those standards to the uncrewed or remotely operated craft. And then the one at the end, MGN 664, was the first legislation or regulation put in force, but still remains very valid, as this covers everything outside the workboat code or otherwise. So a vessel, for example, that is above 24 meters in length, or that is using more autonomous features that would not be classified under the definition of an ROUV. And we anticipate this will continue until such point that further legislation and regulation, either international or domestic, becomes formalized. But it's working well. We're seeing various projects across all three at the moment, which is good. In the UK, we have several vessels operating commercially now, mainly in the survey domain, and they've been developed and certified using a combination of either previous workboat code versions and MGN 664 or general load line exemptions. And we are starting to see an interest now in short sea vessels in the North Sea, say between Belgium or Netherlands and the east coast of the UK. And finally, then, a bit of a touch on the navigation specific aspects where I ply my trade. These are some of the aspects we've looked at mainly on a case-by-case basis, or when chatting to operators in the early engagement phases. But obviously we have fed these back into policy and developing our guidelines for how vessels should operate. So safety cases such as what vessels and how they should operate with a loss of cameras, but with still control, situational awareness and how to maintain that, introducing the use of electronic charts and logbooks, especially when in remote operating centres, when paper is becoming increasingly difficult between multiple locations. And with our radio team has looked into GMDSS requirements. Most of these are based around the absent mariner, as we call it, the mariner being removed from the vessel. So much of the principles are the same, but how do we ensure that they are upheld when the vessel is separate from the location of control? Engagement at IMO, I've mentioned input into the mass codes. Most recently, the navigation chapter was all but finalised, or certainly take a huge leap forwards, which was very positive. And we inputted there on, again, electronic charting and electronic data use. And autonomous navigation systems, I'm sure we'll touch on during the Q&A, but that is a phraseology that has been born from the IMO, and still quite a few unanswered questions about how that will be regulated. And finally, what's next? Well, I mean, a lot of things, of course. Cholera compliant software is always on the tip of everyone's tongue. As yet, we've not seen or been approached to assess or approve anything under the UK at present. We are seeing various guises of it in research or testing, but most of them come up very short, unfortunately, of what would be certainly the requirement of a conventional mariner. Bridge technology, moving away from autonomous navigation, just the advent of things like AI lookouts or increased automation on the bridge to assist the mariner rather than necessarily control the vessel. And of course, the long-running position and communication resilience, so PNT and otherwise. How will these vessels know where they are? Do they require extra facilities to navigate themselves if the mariner is disconnected? A whistle-stop tour. I apologise, you've had to. I'm sure your willingness to listen to my northern tones has waned now, but hopefully that gives an overview of where we are with the UK and what we've been working on. And as Ivana said, I'll be present for the panel Q&A sessions at the end. So I won't ask for them now. I'll feed back later on. Thank you very much for listening.
Thank you, Simon. That's brilliant. Definitely lots to think about there. I'm now going to hand over to Commander Michael Hutchinson, Royal Navy, who's the current captain of the Patrick Blackett. Michael, over to you.
Hello, everybody. Good morning, and thank you for having me here. I think I am 24 years into the Royal Navy now. I am a warfare officer or a seaman officer, which I guess is the equivalent of a master mariner, but we have the complexity of needing to be able to fight a ship on top of that. Patrick Blackett is the third ship that I've commanded for the Royal Navy, and if I'm honest, it's probably one of the most exciting projects that I've been involved with. I've always enjoyed technology and being at the sort of the cutting edge of innovation throughout my career. So finding myself in Patrick Blackett, where we're trying to do some really interesting things in the autonomy space, is a real challenge and privilege. So if we just move on to the next slide. So I work for an organisation called Navy X. Navy X is a part of the Royal Navy that look at what the future is going to be. So it goes from big programs like future air defenders to future frigates to military data gathering and all that kind of thing. And we're based out of NCHQ down in Portsmouth under the umbrella of the Develop Directorate. What we're specifically charged with is the acceleration of autonomy, innovation and lethality into the fleet. And that can be a combination of those things or bespoke things as well. We're a pretty small organisation, which has a bit of a resource challenge at times. We're about 22 people. That sort of does veer and haul, but the ship's company is only 5. So she's not a big ship at all by any stretch of the imagination. She's only 42 metres, but we run her with 5. And then the rest of the team are looking at planning the project and looking after the platform requirements for the 3 platforms that we operate. Mad Fox is one of them. She's a little bit bigger than APAC and is a fast interceptor capable of I'll call it IMO degree 3. APAC is the standard Pacific 24 SeaBot that the Royal Navy employ, about 7.5 meters, and it's fitted with an autonomy stack. So, a good prototype to test and evaluate an optionally crewed platform that can be fitted with a weapon system or launch and recovery to be able to augment an in-service frigate destroyer. And then Patrick Blackett, which is the newest platform that Navy X have, and she's a Darman fast crew supply ship by design. They're 42-meter oil rig supply ship, really, and we went for that deliberately, and I'll touch on that a little bit later. Next slide, please. So that is APAC. For those of you that recognise Royal Navy SeaBoats, you'll see that it is a standard platform with, in that picture, she's got a 50 cal gun on the front, which is a remote weapon system, and then the autonomy stack behind that, and then the mast with all of the sensors and that kind of thing at the back. That platform we have been operating over the last 4 years. I suppose it's getting to be a little bit legacy now. We have integrated with a Type 23 at sea. We've completed the land-based firing of the weapon system to prove that it works as a remote weapon system. We've completed a whole load of work at a reservoir up in Raysbury to test and demonstrate to the Defence Maritime regulator that we could operate the platform safely. And then we've done a whole load of work where we've operated the boats in true degree 3, so with no people on board at all, over in Reckless, and that's from end to end. So sailing the boats, taking it off to do a tactical mission and bringing it back, all in remote operation. So operated either from the remote operating centre, and ours is deployable, so it's a bit more ruggedized than some of the centres that you might see, and also we can fit it onto the back of the ship. Next things for that platform, where the gun goes, there's a launch and recovery system. As I said, it's a prototype, so we can't put them both on at the same time at the moment, but that allows us to demonstrate that we can recover that platform at sea. So that's what we'll do next, down on a rig in Plymouth, and then firing the system at sea, and launching and recovering from a frigate destroyer. And when we've finished with that work, we'll have demonstrated that we can fit standard SeaBoats with an autonomy stack to allow them to be used for tactical missions by frigates and destroyers. We move on to the next slide. So this is just some of the pictures. That's the ship operating with the SeaBoats in degree 3, and what it's doing there is some pattern of life work, some reconnaissance patrols and that kind of stuff, working with the Royal Marines and some of the Portuguese Marines as they were doing amphibious assaults, and force protection for platforms going in and out of harbour and choke point transits and that kind of thing. And that is Patrick Blackett next to it. Next slide, please. And what we're trying to do with Patrick Blackett is a couple of things. Accelerate equipment adoption into the Royal Navy. So those of you that know anything about the Navy will know that we haven't got as many as frigates and destroyers and frontline assets as we did once upon a time. These things are expensive, they're high value assets, and we've got to preserve them to do the missions that we need them to do. So one of the reasons that we brought Patrick Blackett in was that she is capable of carrying 4 20-foot ISO containers or 2 40-foot ISO containers on the back deck, and that allows us to load on new weapon systems, new radar systems, new command systems that we want to bring into frontline service, take them to sea and test them, and adopt them into the fleet more quickly. It allows us to operate with a whole load of autonomous systems, so air platforms, subsurface platforms, and surface platforms, to really investigate how autonomy can help us with lethality and improving the ability of the Royal Navy to go out and fight. And also the testing of new weapon systems allows us to really get into that as well. And then the ship itself, what we are trying to do is to get it to IMO degree 4 autonomy. And what I mean by that is that the ship is capable of navigating itself. Our use case for that is effectively a lap of the Isle of Wight. And the reason that we've chosen that is because it's congested, difficult waterways, and we want to make sure that we are Colreg compliant. But that's only the start, really. For us, what we need to do is we need to get to a point where a ship like this, and it won't necessarily be this one, but a ship like this can operate alongside an in-service crewed asset so that it can be a partner, a wingman. It can take a sensor up threat, it can take a weapon system up threat if we need it to, or it can augment a force, carrier battle group, whatever it may be, and just allow us to generate mass without having necessarily to spend 1.2 with 15% defence inflation on a Type 45 destroyer. So you're getting on for, I don't know, £1.5 billion platforms now. So it's a way of getting mass in a cost-effective manner. Next slide. So the way that we do that is we've with Patrick Blackett, we have bought the platform because of its functionality that it offers. I'm sat on board the ship at the moment. We've got plenty of space. We've generated our own open compute environment. What I mean by that is the ship is open to take a whole load of software and technology and embed it into the ship without any difficulty whatsoever. All of the ship's sensors and equipment is connected into this brain as well, and it allows us to test and evaluate a whole load of equipment that will allow us to test degree for autonomy. And the first thing that we're going to do in the new year is fit the ship with an autonomy stack. So it won't be connected, but it will be demonstrating on the bridge to me what it would like us to do. And we're going to gather the data to see whether it's working properly or not. Evaluate it, refine it, and keep working with that particular provider so that we can get to a point where we are able to start using simulation to demonstrate our ability to navigate with the computer. The next thing that we need to do after that is get the sensors onto the ship. At the moment, we've got some sensors, but they're not the ones that we want to keep. So a whole array of sensors going into that autonomy stack and the open compute environment to make sure that we are linking everything up. And then at that point, we'll be able to start operating it effectively. And I imagine that the time frame for that is about sort of February to March kind of time. If you look at the next slide, this is a sort of a roadmap of where we would like to be. And I'm not going to go through all of it. There's a lot that goes on into making this work, and it's quite a complex project, and one that we have got to, because we're at the sort of the leading edge of this. Really, we've got to take the regulators with us, and that's both the defence regulator and also we've got very good links with MCA, and we had an MCA team out to Portugal with us looking at how we were operating the remote system that is APAC. So we're at the point now where sensors will be fitted. An autonomy stack will be fitted in January, February kind of time, and then we'll be ready to start testing it. At that point, we'll think about removing the air gap and allowing the autonomy stack to actuate the ship's rudders and engines. Next slide. And as I said, that's partway through what we need to be. The end state is something that we're calling autonomy. And that's really difficult because actually, we're talking potentially operating in a comms denied environment. And how do we reconcile that? How do we prove that the ship is going to do what we need it to do? And how do we get the ship to a point where it is able to position itself in a task group to contribute to the defence of that task group or the mission that it's been assigned? Because in warfare, there's lots of different domains, the air, the surface, and the subsurface battle. And depending on what the fit out of the ship is, it needs to know what sensors and capability it's got embarked so it can position itself to have best effect on a task group. And clearly, the crawl, walk, run that everybody is familiar with is a difficult sort of way through this, and how we get to the point where we are demonstrating that the system that we have embedded into the ship is safe, that it is Colreg compliant, and that we are able to use it. And I don't necessarily think that is a completely uncrewed system, but one of the reasons that the Navy are interested in it is because it allows us to free up our people resource. And it means that a ship like Blackett with a five-man mission team, we are able to operate an autonomous system from the back of the ship while the ship takes us from A to B, carry out a mission, and then recover that system and the ship take us to the next place that we need to be. So we're not talking about completely unmanned and uncrewed, and clearly we can go and interact with the ship if we need to. And it's that flexibility that allows us to get the most out of these platforms. Next slide. And it won't surprise you that there's a whole load of challenges. The technology is developing very quickly. We're working in sort of spaces where this, some people have done some of it, but not all of it, not all of the different areas that we need to navigate in to prove that you've got a system that can do anything. We are very heavily resource constrained, but the benefit for us is that it allows us to really extract the maximum from autonomous platforms for the future air defense concept. It allows us to generate mass at a cost-effective price point, and it allows us to really sort of lead the way on this and make sure that we can deliver something of value to the Navy. Next slide. That's it from me. Thanks very much for your time, and I'm happy to take questions when they come up later.
Thank you, Michael. Fascinating to hear from someone who's actually working on the ground or at sea with the equipment. I'm now going to hand you over to Gordon Meadow, who's the founder and CEO of SeaBot Maritime. Over to you, Gordon.
Thank you very much, and again, yeah, thanks to previous speakers. Really interesting stuff, and it's fantastic to be part of such a great panel. Kind of the focus in the kind of the areas we're going to look at today. So a by way of introduction to kind of echo previous speakers, like Simon, you can probably read the bio from the introductions, but primarily Gordon Meadow, CEO of SeaBot Maritime. I'm a chartered marine technologist and fellow of IMRS, and I'm a fellow of the Higher Education Academy. I run a business that we specialize in maritime training consultancy and integration of new technology into maritime operations. We've kind of got three verticals that cut across consultancy, research, training delivery, training development, and training courses and uncrewed systems, and also ed tech development to try and help kind of companies across the maritime sector develop and assure competency with the kind of focusing on aligning human expertise with emerging maritime technologies. That's kind of focus where we are as a business. Next slide, please. So what I'm going to focus on really is, as I do an awful lot, is about the importance of the workforce in this kind of journey. Autonomy and automation and uncrewed systems doesn't mean no people. Kind of the threats sometimes is kind of common expression used now, but the threat to roles really isn't from AI, it's from someone using AI in the role. So I think reskilling and upskilling is really key to this, and for many years now we've been championing the key role that the workforce and seafarers play within our global infrastructure and global economy. What I'm going to focus on though is the kind of the practicality of it in terms of integrating our operations with these types of new systems. And actually, when we talk about autonomous ships and AI, it's our view that you already have autonomous ships. Actually, we've built a really good job in building a kind of global infrastructure, and actually ships don't really run into each other that often, but there's always ways of improving safety and efficiency and systems and so on. But when I understand the autonomy, I look at it in terms of functions. functions on board and how we integrate complexity into those kind of procedures. We've moved from very manual to automation of the the brawn to now it's kind of automation of the brain. So working in all across all of these functions, it's what's fit for purpose and what is a relationship as humans with the technology. And we're moving into an era where we're working towards to co-collaborate. So it's not just about the knowing and the doing and the knowledge and skills anymore in terms of what we understand. It's about maintaining our overall competence and how we gain experience. So it also incorporates our behaviors. In addition to that, when we think about competency frameworks, actually it's now about the knowing, the doing, and the behaviors and how we co-collaborate with complex systems, because we need to understand their capability and how we can combine to benefit from the technology. And it's more about emancipation of the workforce as opposed to replacement of the workforce, and that's really it's a key message. So we look at all these functions. These are kind of common functions that cut across shipping, but there are lots of use cases for autonomy and implementing in the maritime. We've heard from Michael and Simon some of that. I'm going to look at kind of 3 examples of emerging use cases for this equipment and how it's been used and how it relates to how the workforce is getting involved and the different types of skills. So if we skip to the next slide, please. So if you did a search in the internet, 10 years ago, actually, you would probably see kind of that imaginary, the future autonomous ship in the middle, and an image. And more often than not, new technology comes along in through a hype curve or a cycle where companies are trying to enter the market with new products and so on, and there can often be an overplay where the technology actually is, and they understand that more effectively. We use things like hype cycles and so on to be able to see, well, okay, here's the technology coming, here is what it's being used for, and how it's actually being applied. And more often than not, we fall into in the hype cycle something called a trough of disillusionment, and in the trough of disillusionment, after the hype, it's the workforce that is the thing that actually implements it. People have got to build ships, people have got to operate ships, people operate systems and so on. But there are lots more emerging use cases for these systems. If we jump to the next slide, please. This is the first example of one of those use cases. So we can see here, this is a offshore application. Is a company called Fugro, who we have been developing the workforce now for I think the last 4 or 5 years. Helping them to be able to onboard these new systems. Now, when you look at this, I put it in the picture back of a lorry because it's trying to contextualize the size of it. But actually, the complexity of this vessel is where this used to be a 70-meter vessel, it's now 12, and kind of moving kind of the 18-meter mark. And there are different companies now onboarding these types of operations. So this type of operation is a combined surface subsea. So originally this vessel was designed to be able to travel uncrewed with a shore or distributed teams with people located in different locations for different purposes. So this originally designed was to deploy an AUV, and the AUV would then be launched and carry out its work and then come back on board. It was redesigned to deploy remote ROV. So this vessel goes out into the field to be able to do subsea surveys, subsea inspection, bathymetry, those sorts of things using fully operated vehicles. This uses combined teams. So command and control is really important in terms of the skills, understanding the complexity of the system, what it can do and what it can't do. But it's about mastering not just the competencies and new competencies, but it's also understanding when things go wrong and how things go wrong. So a more in-depth understanding of failure modes and how to navigate these sorts of failures. Or for example, I have to apologize today because my camera isn't on. I use Zoom and I use Teams all the time, but it isn't working today. So it's sometimes we work with technology and it's difficult to understand what it's doing if we're not trained effectively and part of it as a system. So this is the first example here. So this type of vessel may look small. If we switch to the next slide, please. but actually the complexity behind its operations are equivalent to complex operations. So actually, the level of competence within the workforce equates to a 70-meter vessel or an 80-meter vessel, and the types of professionalism in terms of the operations. So whilst we may see 12, 18, 24-meter vessels, the competence of the crew has got to still maintain at the same professional standard depending on the type of operation. And that's an important element then to be able to develop the workforce and the competencies around it. So that's your kind of offshore oil and gas and companies benefiting from miniaturization, not about vessels getting larger. Move to the next slide, please. So here we are. We saw Mike from the Blackhead, and also different types of operations. We've got Task Force 59, which actually just concluded in the Middle East, which is about testing and evaluating these trial and these systems. But also, as alluded to earlier in the Ukraine, we've got use cases for the here and now, where the Ukraine are at war. They are working on a just in time or a marginal gain effect. So they're thinking, what can we do with this, and how can we deliver on it immediately? And it's a very different mindset. So whilst, example, in defense, there's a large focus on trialing and understanding the art of the possible and deploying the systems. If you're physically at war, then marginal gains are the important next step, and you're developing operations in an unregulated sandbox, and your workforce developing at the same time. There's actually a big lesson really to learn here, because marginal gains are a key as long as you understand the purpose of what you're trying to achieve. If you know what the concept of operation is, then you can work back from that. But the key is ensuring that it's not the technology, it's just the focus. It's in terms of workforce development and competence and skills and bringing your workforce forward as well. The last example, next slide, please, is an organization called SeaFar. So SeaFar are operating on inland barges in 3 different countries, and then looking towards operating in kind of the open sea regions. They've just signed an MOU with Fast Lines and to kind of explore this. When you go and you visit SeaFar, so the operators are trained to a different standard, which is CEVNI, inland barge operations. Where we have shipping, for example, we're trained to SCW. I'm going to put it that way. The core skills, and that's the difference between what these operators are doing and what you might do on board a bridge of a ship in terms of training, is that these operators' core skills are actually maneuvering and understanding bank effect. It's not necessarily the huge area of navigation or the collision regulations or an officer watch. And the route at which they train, they start off in operations and understand the experience, and then in maneuvering and understand that and master that, so they can use it and apply that remotely. If you look at your conventional route for an officer of the watch, actually an officer of the watch trains primarily to look after the watch the first stage, and maneuvering isn't something necessarily that you engage with and develop and master in those early stages. So depending on the use case, it very much depends on the developed skills and the experience that you need for it. So it's not about one size fits all. It's about understanding the different types of operations and the different types of application and where those core skills are and where those competencies lie. Next slide, please. So we're in this kind of era. It sounds cliche, but this connected workforce, connected mariner. It's a ubiquitous term that's affecting all kind of sectors and how we're linking into systems. Next slide, please. I think the key message, however, though, is for us anyway, to steal a Lockheed Martin term, future workforce is human more, not human less. And going forward, we should not only look to replace humans in certain tasks, but also to empower them with new skills to work alongside technology, performing shared tasks and using shared decision making. It's a crucial message. Next slide, please. And hey, if you're any doubt as to your role as a seafarer within the future of this industry, Jim Kirk's still on the bridge, so hopefully you'll take that as a bit of guidance. Thanks very much. I'll leave it there.
Lovely. Thank you very much, Gordon. I quite agree. And yeah, it's so important to look at progressing humans alongside technology, autonomous or otherwise. So we'll move on now to Paul Burton, who's at the UK Hydrographics office. Paul, over to you.
Thank you very much. Yeah, sorry, my camera, thought I was going to do a Gordon Meadows then, but my camera has sprung into action. Good. Yeah, good morning, everyone. And again, thank you very much for giving me the opportunity to present here. So I work for the UK Hydrographic Office as the Mass Technical Engagement Manager, which is really gathering requirements from a data perspective, for a navigation data perspective to support mass operations. So next slide, please. Okay, so what's the problem with data and to support navigation? We've all had electronic charts for quite a few years now. They all ingest nicely into the machine. So what's the problem that we see? I guess where we come from is that we've spent over 200 years finessing the data products and services that we provide, all optimized towards human decision making, and all our products and services are optimized for that. And of course, if you move into the autonomy space, where you're looking at potentially autonomous navigation and autonomy, making the decisions and planning the route, that's a very different problem space. So I'm not really looking at remote operation centers where humans are still very much making the decision making. We're really looking at the area where you've got autonomous navigation systems, regardless of whether you've got people on board or not. But where you are delegating at least some of the decision making down to the autonomous navigator to do. So some of the things that we see and observe and question about how fit it is for autonomy here. So you've got top left data inconsistency, where because of either the provenance of the underlying data we received or just in terms of updating charts, you have what we might call data tears across certain areas, which a human navigator would well understand what is going on there, but or an autonomous navigator may not expect to see. Data density, bottom left, where you get very highly accurate, highly defined multi-beam surveys surveying the bottom. Even on electronic charts, we decimate that dense, rich data because humans don't cope very well with hundreds and thousands of data points. What they want to see is the so what of contour lines and sparse spot depths, so that they can make their decisions not cluttered with a lot of information. Computers, in a sense, work exactly the opposite way, and like nothing better than giving the full data set to be able to define and work out what they want to do. And sparse data points don't really work very well for them. In the middle, data provenance. That's the source data diagram off a chart for an approach to a reasonably major port in the world. Yeah, and there you've got data reasonably recently surveyed for the port approaches, sitting right next to data that comes from 19th century lead line surveys. Again, hopefully, a human navigator takes account of that and factors the provenance of the data, where it's come from, into his decision planning and navigation route. And again, autonomous navigation systems need to understand that provenance of data that lies behind it. Merely because it's a point on an electronic chart doesn't mean to say that it hasn't still come from an 18th century, 19th century lead line survey. And next to that, there's a note there, textual note, which basically says there's all sorts of dragons around here. Be careful. And again, what is an autonomous navigator going to do with that note? And then on the right, leading into that, is text-based information. So it's not all about just the chart. There's a lot of other publications, information that goes around that chart, giving situational awareness and direction to the mariner as he plans his route and executes that around speed limits and all of that sort of things, locked in sailing directions, which, if you know sailing directions, are very text-based, natural language publications, and again, on Autonomous Navigator, what it's going to do with that if you present that to it, and then radio navigation warnings, also text-based. So that's the kind of problem space. Next slide, please. So what are we doing about it? So I expect most will have known, but if you don't, the International Hydrographic Organization, the IHO, is revising its hydrographic data standards in something called S100, the Universal Hydrographic Data Model, which is a refresh of its standards, so replacing the S57 ENC with something called the S101 electronic navigational chart, but going much further than the chart and providing a holistic data model for all maritime data that hopefully will work together and be fit for more modern use. Now, while it's not necessarily optimized still for autonomous navigation, it will take us much closer towards support to autonomous operations. So things like S102, if you could just click the slide again, S102, which gives you the dense bathymetric surface, and those other ones that are highlighted in red there, which are the phase one of the products that IHO are looking to release into the maritime domain over the next few years. Next slide, please. And so alongside of that is an IHO mass navigation project team, which is basically looking at all the development of those new standards, looking at what industry require, and ensuring or seeking to ensure that those standards meet the needs of mass operations, and not only in the IHO domain itself, but across the international domain, including IALA, the World Met Office, and the IMO as well. And so I would encourage you, if you are involved in this and you have requirements that you feel are not being met currently by the products and navigation products and services that are extant, I would encourage you to get involved with that and provide your requirements. So next slide, please. So just to sum up that, you know, and again, to reiterate that point, international data standards take a long time to develop. They are, you know, new standards are being developed now. Now is the time. If we want to get stuff in to support mass that you know, in your operations or development or trials, you feel are not there at the moment, then now is the time to try and get those standards influenced so that they meet the requirements of mass. What we don't really want to do is create a whole new suite of standards purely for mass. We want standards and the data to support conventional and mass operations. But it's not just the standards. I think we need to recognize that data production to those standards takes a long time as well. Production constraints in hydrographic offices mean that we'll be dual fueling S57 as S101 probably for many years to come. Adequate survey data will not exist necessarily to support S102 in many places. And so that raises a question, perhaps not a very popular question, and I'm not saying it does need to be, but I think we've got to look at, do we need to evaluate the underlying data that supports the products that we push out, and say in some areas it's not adequate enough to support mass operations. And then the final point is really that a significant amount of maritime navigation and situational awareness information is locked away in text-based natural language format products. And we've either got to look at unlocking that and putting that into much more vector type information, so it's machine readable, which is going to take a long time for hydrographic officers to do, or we need to look at the evaluation and development of large language models to be able to ingest that and make meaningful navigation decisions based on it by an autonomous navigator. So I think that's it from me. Thank you very much.
Thank you, Paul. I'll now hand over to Caitlin Bentley, who's the Senior Lecturer in AI Education at King's College London. Over to you, Caitlin.
Thank you so much, and it's lovely to be here with you all as well. I am not historically, I do not have a background in the maritime sector, but what I have been thinking about for the past few years as a co-director on a Center for Doctoral Training for Safe and Trusted AI. We're just starting up a new doctoral center on robotic surgery and personalized intervention in healthcare. And I also work across many different sectors and disciplines in the Responsible AI program that's led by the University of Southampton in collaboration with King's College and Nottingham and a variety of other universities across the nation. But I have been thinking a lot about what maritime sector actually looks like. And it's been incredibly hard to get a clear picture actually of what specifically the types of AI that are being used in mass. And as you saw with Michael's presentation and also Paul's presentation about the different types of data that are needed, I think it's useful to emphasize that there are actually a lot of different types of AI, and it's important for us to recognize this when we speak about AI and autonomous systems, because the types of AI that you can use will have different costs and benefits when you think about procuring them or embedding them into a ship. They have different strengths and weaknesses in terms of efficiency, effectiveness, assurance, and then of course they have also different risks and vulnerabilities. And when we speak about AI at a general level and sort of at a systems level, we lose sight of some of these key differences. So in general, there are three main types of AI, and now we're seeing increasingly hybrids and combos of these. And so the ground is shifting. And also need to symbolic AI starts AI planning algorithm predict much more difficult and intensive to create. You need like sort of very clear delineated types of knowledge systems, so not great in terms of navigation to deal with adapting weather conditions or what have you. In terms of machine learning, there are a variety of different sort of data-based algorithms which create predictions or learn from data that's collected or distributed to make its predictions or trigger an actuator on a boat, for example. In mass, there are a variety of sensors and actuators that are required to function well in order to operate certain functionalities of mass. And then what we're seeing now, because of, in particular, machine learning's, when it uses data to kind of learn and understand how to make a prediction, we don't actually know what happens in that process. So that's what we call like the black box of AI. So it's not explainable. It can be unpredictable at times. A lot of the times, oh, might need to turn my camera off. Sorry, my internet today is not great. Okay, sorry about that. In terms of the explainability of machine learning, there's sort of a black box quality to these types of algorithms. And so what we're seeing now are combinations of symbolic and neural net types of artificial intelligence to try and make things more explainable, more assured. But that's, of course, changing, like you can, as I'm seeing here, you can have types of computer vision that use either just machine learning, or you can have types of computer vision that uses neurosymbolic types of AI. So it's really important in terms of understanding these risks to be specific about the methods of AI that we're using. And I just wanted to, can you change the slide? Show how, when we talk about components of maritime autonomous systems, you can often have different kinds of AI used for the same types of components or functionalities. And with that, it can mean that even if a type of AI does a particular function, it can introduce different kinds of risks or costs and benefits that we need to be aware of. And if we don't have that kind of awareness, it's difficult for us to have that kind of assurance at a systems level in places where, like, let's take, for example, just the route planning. You could have different approaches to optimizing a route. If you were to take an expert system, you would need to have sort of a complete picture of all of the different risks or routes that are available, and to have clear rules around how ships should go, which is not, it's very reliable and explainable, but maybe not realistic. In terms of reinforcement learning, it's much easier to adapt, but it takes a huge amount of quality data that Paul was mentioning. You have to train it in those conditions where it's likely to operate. Anytime you take something out of that context, it's very difficult, or it's very likely that it's not going to be able to respond to that new environment. And alternatively, with predictive analytics like machine learning, if you are training a machine learning algorithm to optimize your routes, you would be using historical data. And so what concerns me there are things like if we have climate change, or changing weather patterns, or changing conditions, or bodies of water, things like that, then it's not going to handle those new conditions either. And of course, many of these different types of algorithms would also rely on the sensors that are feeding it with, the positioning, as many of the speakers have mentioned as well. So this complexity around the systems of systems that Michael was also talking about is really important to keep in the back of our mind, but it's also important to be specific about which technology some of these components are using, and how we are going to sort of weigh the benefits and costs, or the risks associated with using different types of methods. And I'll stop there. We can get to the questions if you want.
Thank you very much, Caitlin. That was a really interesting insight into AI on maths. So I'd now like to invite the audience to start getting their questions in for our panelists. It can be open to all the panelists, or you can specify to answer your question. I'll kick us off with you. Simon, I've got one for you from our last webinar. And the question was, using the 4 mass levels, how do you see the coexistence of vessels across these levels? And will legislation move towards perhaps enforcing only levels 3 and 4 to enter certain zones, such as busy ports or busy shipping lanes?
Thank you. Yeah, a fascinating question, and quite a few different aspects to it. But I think the general answer is, in the final result, whenever that may be, then hopefully not, or no. In the many ways that what we're trying to do is ensure that, of course, both internationally and domestically, that a mass, shall we say, is as safe as, or at least as safe as, a conventional vessel. And what we don't want to see is splitting between where vessels can operate just because of their mode of operation. One, for a number of reasons, but one because, again, if we're deeming a, say, fully autonomous or remotely operated vessel, this alludes to them being sort of unsafe to enter certain zones in the vicinity of other vessels, then they should be at that level where they can operate as such. And also there's an aspect of not wanting to, and this is something the IMO is very hot on, is not wanting to specifically benefit or bias towards a mass. So give them any freedoms that conventional vessels have, or of course the opposite, give them onerous restrictions that a conventional vessel doesn't need to adhere to, of course, as long as they meet that safety minima. In terms of the 4-mast levels, I know Commander Hutchinson mentioned it quite a bit as well, and it's a funny one because officially they're not in use anymore. And it's a real shame in some respects because they became so ingrained, and it's the IMO's own invention, as it were, that everyone talks of those 4 levels now. Officially, they're not in use. Of course, that doesn't mean they are invalid. It's just the terminology, really. But as I mentioned to you before, there is already now a blend between how vessels will operate. You'll never get a vessel that is autonomous only without a human input available, etc. So in terms of high volume shipping lanes, certainly legislation is not aiming towards them being restricted. In fact, we're saying the otherwise, that say vessels should be able to operate in those areas. Conventional mariners who are still at sea, of which that will always remain as far as I'm concerned, should be able to act in the same way as they would seeing any other vessel approaching them, in the same way that a mariner on the bridge, when considering action, say under the collar eggs or otherwise, should put themselves in the shoes of the master or the person on the other bridge to say, how will my actions be interpreted, and are they in accordance, if necessary, with the rules. What we may see, in similar ways to where you see in the Dover Strait on chart notes, etc., there are concentrations of crossing vessels where ferry routes go. There may be times, depending on operations, where that can be mentioned, but again, that's not putting restrictions on, and there is a fine line to be tread to avoid people having to take extra vigilance or action against a vessel that should be deemed as safe as any other vessel they see on the seaways. So in terms of ports, obviously, legislation allows ports to regulate their own waters. I won't go into that now, but at the moment, nothing is changing in that sphere. The discussion hasn't really started in that, so I don't want to step on anyone's toes there. So hopefully that is a bit of an answer. I think, in summary, I wouldn't like to see that. I think that defies the point, really, and it starts as a bias, and force companies or operators to think one way or the other about how they do this. And I'd be interested to see if there are any other views on that, from either audience or panelists.
Thank you, Simon. That's brilliant. So I do encourage the audience to use your Q&A button at the bottom, or wherever your panel is, to interact with the panelists. For now, I'll keep asking the questions. I'm very happy to do so. Gordon, I'd like to ask you, when people are coming to your company, what are their biggest concerns regarding the driving of progress of autonomous vessels and remote operating centres?
So it's fairly easy to answer, actually. It cuts across kind of 5 or 6 different areas. So it's change. It's managing change. So when you are doing what you're doing, then you're kind of confident, more or less confident in your operations, as long as you maintain the status quo within your workforce, the competence of your workforce. And back in the day, things used to move slowly. You trained, you did your job, and actually you would probably be able to be competent. You did your apprenticeship, whatever you did, or you gained experience, and you were able to complete. But the world moves much faster now, and technology moves much faster, and all of us must kind of cope with the technology. So from senior leaders to kind of the workforce, everyone's trying to grapple with changing nature of the industries and the technologies coming towards us in every sectors. every sector is experiencing this, from banking to trains to maritime. We are just the causal effect to us. So there's actually a common theme, not just in maritime, but across all others. So things like workforce upskilling, that's a real challenge, ensuring that existing personnel are trained to operate and manage advanced systems, and that you have the complexity within your workforce. Regulatory compliance is a really crucial one because we've all got to be compliant. So our customers are navigating kind of evolving regulations. The regulator who, and more often than not, regulator can be beaten up, right? But try being the regulator, and that's the same in terms of trying to cope with the evolution of these systems. So working hand in hand and helping to kind of facilitate those relationships, but certainly regulatory compliance is a difficult one. Proof of systems, where we have found is that instead of trying to build key trust in systems, about trying to build trust in the people who then can regulate the risk within controlling these systems. It's not just about proving the technology, but it's assuring them as well sometimes. So integration of control systems, that's a difficult one, because if you look at shipping, for example, you get your main control system, you can Actus. It's not necessarily complex. You've got, the S100 standards being developed, for really an eon, and implementing that and so on. You got your conventional setup. Well, actually, control system for operating uncrewed systems is more complex. Decision support systems and so on, how we deal in complexity of those in terms of processes. Safety standards, again, our companies are worried about maintaining and enhancing safety protocols based on different types of operations, and rewriting standard operating procedures. That's where they find complexity. Another couple really is around operational reliability. So you buy something, but you don't necessarily know what you've bought. You think you should be using that, or you have to try and test. And companies don't have the capacity to be able to buy something, test for 5 years, and then deploy it. Not all companies, and that's a big challenge. So they're running along, trying to stay stable at the same time. And the last one is cost of implementation. Every business, it comes down to balancing investment in new technologies with operational budgets and return on investment. That's what business comes down to. I think I'll finish by saying that the kind of clear mantra in business, and I apply it to all kind of areas, the cost of change has got to be less than the cost of staying the same. And that applies to anything that you do. But the bottom line is, what's the cost benefit? Why should we be doing it? Not because it looks fun. Hopefully that kind of summarizes the areas. Thanks very much.
Thank you very much, Gordon. And we did explore that in our I think our first webinar, actually, on our introductions. It's a very valid point at the end there. Thank you. We have a question in from Stuart Matthews. How do autonomous vessels cope with reduced visibility and adopting a safe speed when other manned vessels will be proceeding at a slower speed? So we did look at the sensor suite in our second part of this webinar series. I think I could probably answer this one, to be honest. I mean, you won't necessarily find that the autonomous vessels will be the ones going at the higher speed. They potentially could be going at the lower speed. And obviously every vessel is taking into account all the factors of safe speed as per the coal regs. Indeed, some of the ferries going across the Dover Straits don't necessarily go at a reduced speed. It's actually, in some cases safer for them to get across as quickly as they can to avoid interacting with so many vessels. So it will really depend. I think I can answer this. It will really depend on the data coming through, how that system is being operated, how reliable that information coming through is, and generally the speed of the vessels in the surrounding area, exactly what range that visibility is. I don't know if any of our panelists would like to jump in on that.
I'll just quickly jump in to effectively agree. It's a really interesting point and question. people are always asking questions of us about how vessels would, comply with Rule 5. Lookout is the obvious one, and safe speed's the next rule. And yeah, absolutely, there's no reason why the vessel should be going slower or quicker, sorry, than anything around them. So it really depends on, especially remote operated, as Gordon's alluded to, the training, etc., how they use extra skills or need more vigilant skills almost to be able to utilize that equipment to assess that safe speed, and that goes for in clear weather or non-restricted visibility as well, that there are speeds that would be safe and not using. I think the key with Lookout is all available means. So that's not saying that sight and hearing is still not applied, but it's now more because of the increase in technology. There's more technology, and that's what we're looking at, is how that can be used by the mariner with the mariner to assist when they're remote from the vessel. But otherwise, no, I'd agree with your point you made, or your answer you made.
Okay, we got no questions coming through from the audience just yet, but I've got another one prepared. Paul, you did talk a lot about the sort of machine readable data and what we're moving towards, but how close are we to seeing more machine readable charting systems without a human operator? What sort of maybe timescales, and what would that mean for the International Hydrographics Office and the UKHO in developing those? Is it a case of setting up entirely new teams, or is the data there? Yeah, if you could give us a bit more insight into that, please.
Yeah, sure. So I think probably I'll take that on three levels. So one is the standards, the data standards that are being developed, and the timeline for those. So broadly, I think that phase 1, which includes the S101 equivalent of the current electronic navigational chart, ENC. So we're looking at that development or being out there in the streets for the next sort of year to 2 years time, and I think the ECDIS performance standard says that ECDIS may have the ability to ingest that information in the 2026 timeframe. So I think you're looking at 2025, 2026 for those phase 1 product specifications to be out there, and they will take us, I think, quite a long way to that machine readable autonomous support that's there. But the problem with that is that that's not the whole solution. So things like sailing directions and all that information in sailing directions isn't in the phase 1 of the S100. So then it comes down to really how good the technology is to ingest that information in sailing directions and other supplementary information around that could support that. So if you can prove that you've got a large language model that can read that text, human language stuff, can ingest it and can make the right navigational decisions based on it, then that's fine. But if you can't, then I think the ability to re-engineer all that information into machine readable format is a lot of work for Hydrographic Office. So it comes on the technology. Can the technology do it? In which case, that's fine. Our products are fit for purpose. How do you prove the technology can do it is a whole other question that Simon can worry about. But that if it can do it, but if it can't, then you've got a whole re-engineering for Hydrographic Offices, which is a big deal. And then you also come back to the provenance of the underlying data. We are not going to suddenly survey the whole world to support S102 worldwide at all. We know, as often said, we know more about the surface of the moon than we do about our seabed. So that becomes an issue. And then I think, that's again a sort of question, partly for us, but partly for the regulators too, about how much does something like S102, how much is that an essential to mitigate the risk of autonomous operations, and therefore you can operate where you have that dense bathymetry data, but actually you can't where you don't, because getting to a stage where we have, if you want to come into a major port in Western Europe, yes, that's going to be supported. But if you want to start operating, and certainly for the Royal Navy, if you want to start operating in places where often you do not have good data, then the question is, I guess, what is your risk appetite in engaging in an area autonomously where you have poor or sparse or old data. So yeah, I think the timeline for IHO is fairly set between the 2026 and 2029, but there are limitations of that for full autonomous operations, in my opinion.
Yeah, thank you very much. I think we've got a couple of follow-on questions from our panelists now for you, Paul. So, Simon.
Not a question to Paul. I won't drop him in it, of course. But just a slight follow-on point of, I certainly don't disagree with the points he made about the data. But in terms of what we're seeing with vessels utilizing that, what we haven't yet seen in practice or even in concept is, or personally haven't really seen much of, is vessels being able to utilize sort of looking under the surface to see if they're safe. A lot of the concepts we get sent to us have lovely CGI images of going down a fjord or navigating in TSS and being able to interact with beacons, say, or other vessels. But if you look at, it always springs to my mind, it's a bit of a name drop, but when I've sailed into the River Plate, if anyone's been there, that's a vast expanse of water that at times is really only 5 or 6 meters deep. And there's basically a ship's width channel that you all follow, and how, yes, it's buoyed or it's got nav aid, but how does a vessel consider what's under the water as to whether it can make its maneuver to avoid an oncoming vessel, etc. And that really does then stretch the capabilities of, or the requirements of a vessel, which again we take for granted because the human just does that by looking at the chart, in the same way that ENC and ECDIS started to alert the mariner when they were getting close to dangerous contours, which is a step up from paper. But the human made that judgment then as to maneuver the vessel, and it's that gap that needs. So the data will certainly aid that, of course, and it's great to see that coming through. But it's then the applicability of that we're really interested in, as well as just the data. But yeah, thanks, Paul.
Point, Simon. Gordon, you wanted to jump in?
Thank you. It was really to echo both parts of Paul's comments and Simon's comments. I think from Paul's perspective, the likes that there's been a challenge, isn't there, where there's human interpretation from charts to understand what the accuracy is, and put some safety barriers around those due to the changing nature of the seabed. When we look at, and the accuracy of surveys, we progress the survey technology and the equipment, but we've never been able to master the based on the accuracy of the survey from the day and then the subsequent rate of change. And as mariners, they've got to be able to have that experience and depth of knowledge to realize that the numbers that they see on the chart is not as accurate as we necessarily think. And the experience then puts our safety measures around that to be able to work with data that isn't accurate. And I think the use of complex systems and algorithms introduced into the accuracy of data within charting and that accuracy information is just, it's a step change in terms of the judgments that people make decisions on. So I think that's, it's an incredible leap forward to provide the accuracy in terms of the data for the workforce. I guess on the other point around Rule 5, Rule 60, Rule 19, when you think about Rule 19, we apply a different set of rules because it's a complex situation, almost to the point where it's ambiguous whether you slow down or stop, we speed up, whatever, happens, and actually the application to that. This technology, and again, it's misconception is about replacing the workforce. It's not. In some elements, the next stages are about specific use cases, but actually they improve an improved level of situational awareness in those situations where we're making decisions under Rule 19 and going around those processes from safe speed to assessing risk of collision to situational awareness to decision making and around that OODA loop. This technology will actually make you better at your job, and that's the point, is that it's about emancipating you in terms of co-collaborating with technology in certain use cases. And I think it's a really, really important message for me personally and us to get across, really, that it's not just about replacing the workforce, it's about emancipating the workforce in certain tasks to make jobs safer, better, smarter. Sorry, thanks so much.
Thank you, Gordon. Caitlin, you wanted to jump in too?
Yeah, I just wanted to highlight that probably a main reason why Simon's point about these the technologists are not actually developing relevant or solving relevant problems is because I think it's really crucial to have sort of every type of discipline or background and expertise represented here to come together and engage with each other rather than, the technologists working in isolation and sort of solving the wrong problems. And a responsible approach to AI really does highlight anticipating the consequences, is engaging with those stakeholders. And I think for me, that type of co-design process is really crucial here. And it's something that we haven't seen as much as I would like to see.
It's a really good point, Caitlin. Thank you so much. And I guess going back to Paul's point about text-based data and sailing directions, most of these, as Gordon was saying, most of these vessels are have got a case. A user case, so they're operating in a very specific environment that the operator, the master, will have obviously already taken into account. So that data is possibly already held in the mind of the human, which then influences how that vessel is being operated and why that vessel is being operated in that area. For me, the overriding insight of today has actually been from some statement that there will always be a master able to intervene, and that goes to probably the two questions which we've probably only got time for now, is about machine readable data informing a mass vessel as to whether they're on a narrow channel, especially when often the definition of narrow channels are decided in court post-incident. And we've had a similar question about the underpinning case law being incorporated into fully automated Colregs software. So I think these are both regulation-based. Over to you, Simon.
Yeah, it's very interesting. I'm just trying to wrap my brains now as situations I've been in narrow channels and have we defined them and where's it written down off the top of my head. So I think you're right that it is a little bit ambiguous even for the human at times. And of course, sometimes in close proximity to ports, they are defined maybe in the port regulations where they decide to sort of enact that. But again, that's within their waters. More generally, including this point on the call regs, I noticed there was a question that I think Commander Hutchinson's answered, but this is where the call reg compliance really steps up from just being able to follow the rules of the steering and sailing rules, and like rule 2 starts coming in, and that's where, not to defer now to her, but Caitlin would, her AI knowledge would really come in at how this is really mimicking the human's actions and taking in more than just the base level of sensor information about where vessels are. I think a lot of that will be keeping that foundation knowledge, but then the system, if it's doing it by itself, still being able to look at other vessels and thinking about how they're reacting, and say if they think that that vessel is reacting as it would be in a narrow channel, then mimic that. The both, do both vessels think they're in a narrow channel or not? Similar to head-on situation, if you're not sure, then you act as if you think it would be the case. With the master being involved, the next question is, when does the system say, excuse me, I'm not sure anymore, please take over, or please have input? And there's a lot of questions to be answered about that, about the availability of obviously the master. Is it one master for the whole 24 hours, etc.? Which is what we're used to at sea, because they can live in their cabin, but different when realizing the benefits of shoreside work where people may shift swap. So not to go too much into depth of that, but the key is, what we don't want is the system giving them 30 seconds notice, and then of course that being the master's fault or the human's fault. And it doesn't have to be the master, it could well be a remote operator, an officer watch on standby, just sat watching the screens as in a more relaxed state than they maybe would be if they were on the controls themselves. So it's a difficult one to answer, unfortunately, but that is probably a good highlight of the gaps that are missing at the moment, of how complex this really is. With the remote operated vessels seen at the moment, the human's still in control, and it's quite simple, as Gordon and Commander Hutchinson have mentioned, just to apply, they're off the watch, they just don't happen to be on the vessel. when we're starting to ask the computer to do things, ironically, the computer's going to maybe need human input to say whether it's correct or not, which is really difficult. But I suppose that's how AI will learn and develop in future. So there will definitely be stepping stones in that regard. As for us saying what's safe or not in that domain, really very difficult, as I'm sure you can imagine, because there's a million and one different situations that could be, we can't look at all of them and pass individually. So hopefully, I mean, not to sound too much like a politician in that answer of sort of swerving it, but I don't have a direct answer for that. But again, it highlights some of the problems we may face with assessing and assessing them as safe.
The IMO has no plans to amend coal regs, does it, in light of mass?
No, that's correct. And a really good point to bring up. It was MSC 107 back in 2023. Did look at this very briefly. And yeah, the overall thing is the coal reg should apply in full. We were discussing things like Rule 5 as to whether, can that be achieved? Do we need changes? And the concept is, yes, there's no reason why it couldn't. Is the technology there that's able to do it now? Arguably not, but that doesn't mean that we have to, we need to see that come into force. The IMO is actually, in my eyes, working very differently to it has before in writing the mass code, because it's writing it for vessels and technology that don't really exist. Whereas stuff like polar codes, other codes, we're kind of catching up with, maybe sometimes in the wake of a serious incident, such as ISM, for example, and or multiple incidents in that case. So it's a little bit chicken and egg, unfortunately. But no, ultimately, that is the stance. That's certainly the stance of the UK. In future, there's no plans for us to support any changes as yet. But again, the world is open. When we see developments, various instruments get amended in time. But we're certainly not looking to allow other nations to propose changes using mass as a backdoor, as it were, to think that we can slide in. There are, I haven't got no specific examples, but say a country they don't like a certain rule, or they want to push towards more VHF or AIS use, for example. We don't want mass to become the excuse for that. So we're very trying to be very vigilant to that. And thankfully, we haven't had to bat too much away as yet.
Yeah, thank you very much. I'm going to start wrapping up there now then, as we've got to 12:30. I just want to thank each of the panelists for joining us, and thank you, the audience, for providing those insightful questions. As we can see, it's a developing area of industry, so watch this space, and we'll certainly be keeping an ear to the ground to see what the future brings. Thank you all, and do catch up and listen again on the Royal Institute of Navigation's YouTube channel if you missed anything, or you want to listen again. Thank you and goodbye.